Hello everyone, welcome to new class. Today's class is forward biased condition. That is the continuation of semiconductors. So to bias a diode means applying DC voltage across it. So bias means applying DC voltage, and if the positive terminal of the DC battery is connected to the P side and negative terminal to the N side, the junction is said to be forward biased. So this is a forward biased PN junction diode, and when a PN junction is forward biased, so here P is connected to positive and this is negative. So when a PN junction is forward biased, the positive terminal of the battery repels the holes in the P region, because in P region the majority carriers are holes and minority carriers electrons, and in N region majority carriers are electrons and minority carriers are holes. And in forward biased condition, the positive terminal of the battery repels the holes in the P region towards the junction. Similarly, the negative terminal of the battery repels the electrons in the N region towards the junction. Since the holes and electrons have acquired energy from the voltage source, some of these enter into the depletion region and they recombine at the junction, and this reduces the width as well as the height of the potential barrier. And if the applied voltage is gradually increased from 0, the barrier potential also gets gradually reduced until it disappears, and this results in the diffusion of more majority carriers across the junction. A large current known as forward current flows through the PN junction. It is important to note that for each recombination, a free electron enters the N region from the battery and a valence electron leaves the P region to flow into the battery. And the forward current IF is due to the movement of holes in the P region and electrons in the N region, and also the current due to holes and electrons flow inside the PN junction or PN junction diode, but in the external circuit the current is only due to the motion of electrons. Next is forward biased VA characteristics. So this is the typical VA characteristics for forward biased PN junction diode. The forward current IF increases exponentially with the applied forward voltage VF. The applied voltage VF increases beyond the knee value. The forward current IF increases sharply. If the forward voltage is increased beyond a certain safe value, it will produce extremely large current which may destroy the junction due to overheating. Next is reverse biased condition. Reverse bias is the condition that essentially prevents the current through the diode if the positive terminal of the DC battery is connected to the N side and negative terminal to the P side, the junction is said to be reverse biased. When a PN junction is reverse biased, the holes in the P region are attracted by the negative terminal of the battery and the electrons in the N region are attracted by the positive terminal of the battery. Because of this, majority carriers in P and N regions flow away from the junction. As a result, the depletion layer gets wider. The barrier potential is increased by the magnitude of the applied voltage. The depletion layer stops growing when the difference of the potential equals the applied reverse voltage. And when this happens, the electrons and holes stop moving away from the junction due to increase in barrier potential and the resultant electric field. The majority carrier current cannot flow across the junction, and the reverse biased PN junction thus offers very high resistance. However, the barrier potential helps the minority carriers in crossing the junction. Because of the thermal energy, a few minority carriers exist on both sides of the junction, and most of these recombine with the majority carriers. And when this happens, a small current of the order of few microamperes flows in the external circuit, and the reverse current caused by the thermally produced minority carriers is called the reverse saturation current or leakage current. So this is reverse saturation current or leakage current, and if reverse voltage is increased continuously, the kinetic energy of the electrons may become high to knock out the electrons from the atoms, and these electrons available as minority carriers get accelerated due to high reverse voltage, and they again collide with other atoms to generate more minority carriers, and finally large number of minority carriers move across the junction, breaking the PN junction. And when breakdown of the junction occurs, there is a sudden increase in reverse current, and this effect is known as avalanche effect. Avalanche effect. And the mechanism of destroying the junction is called reverse breakdown. Reverse breakdown of PN junction. And this reverse voltage at which the breakdown of a PN junction occurs is called reverse breakdown voltage. Reverse biased VA characteristics. A typical VA characteristics for a reverse biased PN junction is shown. When a reverse bias voltage is applied across a diode, there is only an extremely small current IR through the PN junction. As we increase the reverse biased voltage, there is a very small reverse current, and the voltage across the diode increases, and when the applied bias voltage is increased to a value where the reverse voltage across the diode reaches the breakdown voltage, that is VBR, the reverse current begins to increase rapidly. As we continue to increase the bias voltage, the current continue to increase very rapidly, but the voltage across the diode increases very little above this breakdown voltage. And let us combine the forward biased and reverse biased VI characteristics. So here IF is, that is the forward current is in milliamperes and reverse current is in microamperes. Next is DC resistance or static resistance. It is defined as the ratio of the DC voltage across the diode to the resulting DC current flowing through it. So mathematically we can express static resistance RDC is equal to VF divided by IF. Next is AC resistance or dynamic resistance. The resistance offered by the diode in the forward bias to an AC signal is called dynamic resistance, and it is equal to the reciprocal of the slope of the characteristics. That is, so in the forward biased condition, so the graph is like this. So this is IF and this is VF, and AC resistance is equal to the reciprocal of the slope of the characteristics at that point. So this is slope. So slope means the y component divided by x component. So slope equal to, this is y component, so y component divided by x component, and here the y component is current and x component is in voltage. So the reciprocal of this slope indicates the AC resistance of the diode, and it is also defined as the ratio of small change in forward voltage to the corresponding change in the diode current. The diode applications. A PN junction diode has an important characteristic that it conducts well in forward direction and poorly in reverse direction, and this characteristic makes a diode very useful in number of applications like rectifiers, Zener diode, that is Zener diode in voltage stabilizing circuits, then varactor diodes in TV receivers, and switch in logic circuits, and signal diodes in communication circuits, etc. So that is about the forward biased and reverse biased conditions in PN junction diode. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.